Here's a little video about finding z alpha over 2 scores. First of all, this is what a z alpha over 2 is. If you remember, the standard normal is always centered at 0 and has a standard deviation of 1. So right where that changes from smiley face to frowny face, that's 1 above, and right where that changes from smiley face to frowny face this way, that's 1 below. So that is the standard normal. What alpha over 2 is equal to the area outside, and it's symmetrically arrayed on both sides. So alpha over 2 is that shaded area. So if I'm looking for a 90, let's just say 90% confidence interval, I'm looking for z alpha over 2 where alpha is equal to 10%. 90% would give me a 10% alpha. What that means is that this amount here is 5%, and this amount here is also 5%. I wrote it in different ways, but it's the same number. 5% on the left and 5% on the right adds up to a total alpha of 10%, and that's why they call it z alpha over 2. Because to figure it out, you're going to look for the point underneath the axis where this tail has an area of alpha over 2, where this area right here that I shaded is alpha over 2. So the easiest way to do this is to use the calculator, and that's might as well be easy, right? We don't need to be harder than we don't need to make things harder than they have to be. So let's clear this out. If I'm looking for this point for a 90% confidence, then alpha is going to be 10% and alpha over 2 is going to be 5%. So into my calculator I go, I hit second distributions, and because we're looking for a normal distribution, I'm going to take the inverse norm. If I go the inverse norm for a 95%, I get 1.645. This point here is the point 1.645. What the calculator told me is that it figured out that point where this entire area is 95%. Now, if a slightly quicker way to do it is to, oh, that looks way better. A slightly quicker way to do it is to go like this. I can look at the inverse norm for 5%. What that'll give me, because it's symmetrically arranged around 0, what that gives me is negative 1.645. My calculator has a little glitch in it, but that number is negative 1.645. So that's this number right here. It's unnecessary to do both of them, because once you've got one, you automatically have the other. So using a 90% confidence interval, we'll take a z alpha over 2 score of 1.645. And sometimes you're adding that and sometimes you're subtracting that. Piece of cake, huh? Now, there is one situation where we don't use z. If we are doing a confidence interval for the mean, if we're using x bar plus or minus, and we don't have sigma, so instead of looking at sigma over the square root of n, we're looking at s over the square root of n. In that case, we need to get a t alpha score. And if you have a TI-83 plus silver edition, it's really a piece of cake. We'll get into that in a second. If you don't, and I don't have one here, if you don't have a TI-83 plus silver edition, you have to use this table, the T table. The T table not only has areas under tails, but it also has degrees of freedom. The degrees of freedom depend on how large your sample size is from which you got your S. So let's say we have a sample size where n is equal to 23. If n is equal to 23, then the degrees of freedom are 22. So we take our table and we look at this row right here. The columns are arranged according either to the area under one tail, which is alpha over 2, or the area under two tails, which is alpha. So if you're looking for a Z alpha over 2 score for a 90% confidence interval, either that area under one tail will be 5% or the area under two tails will be 10%. In either case, it's the same. Let's look at see what happens when the sample size is 23. When the sample size is 23, we look over here and we get 1.717 for our Z alpha over 2 score. 1.7, or T alpha over 2. T alpha over 2 is equal to 1.717. And in fact, when we're putting it into a calculator, if you have a calculator, check it out. If you have a calculator and you hit distributions, right under here, you see another thing that says inverse T. Well, then you're in luck, and you can just go like this with your calculator. Inverse T. You have to put the degrees of freedom in first, and then the area under one tail. So like, if you plug that into your calculator should spit out something very close to 1.717. All right, thanks very much. Oh, actually, there's one more thing. Suppose n is large. For example, suppose n is equal to 88. Well, our degrees of freedom would be 87, but when we look at our table, there is no 87. Damn it, there's no 87. We could round to 90, but actually the book recommends that in order to be as accurate as possible, in order to make sure that your table is as large, or your interval is large enough, you always round down. So when t was 87, the degrees of freedom are 86, but we still round to 80. So our T alpha over 2 score, oops, let's go over here. Our T alpha over 2 score for a 90% confidence interval would be 1.664. You'll notice that's very close to 1.645. And down here it says for infinitely large, we just use our Z alpha over 2 score. All right, so that's the nuts and bolts of finding Z scores.